Hello and welcome to the official channel of Design and Simulate. In today's tutorial, we'll be giving a walkthrough of the ANSYS APDL thermal analysis problem, and it's a very basic problem, but it will teach someone who is new to ANSYS and modeling the heat transfer problems that how you can model the temperature distribution and how you can get a temperature distribution on an object. We are keeping it very simple and easy to simulate and understand that how it could be implemented in ANSYS, and in future we can build it on some complex problems also. So initially here is our problem statement. We are just simulating it as a 2D heat transfer problem, and we have this rectangular surface, and on top of the surface we are applying a temperature. So basically this surface is constituent by 4 lines, and we just apply a temperature on the top line of 1 Kelvin, and we are just keeping the side lines as at 0 Kelvin, and now we'll just see that okay, how the temperature is distributed within this rectangular. And basically our aim is to find this temperature distribution on the bottom line. And so we'll just go through this tutorial to learn how to simulate this problem. As we can start the mechanical APDL product launcher by clicking on the programs and selecting this mechanical APDL product launcher program. And similarly, you just need to create a working directory, give your job a job name, and click run. And now here are the preferences in ANSYS. So you need to give it you need to select the thermal option from this, since we are performing a thermal analysis this time, and you just click OK. And now the next stage is the same as we did in our previous tutorials. So we select the element type, and now when you select the in your preferences, when you select the thermal option, ANSYS will only show you the element types that are for thermal analysis. And if you don't select any option in the preferences, then it will show you all the element types. So there will be, then you just need to select your own. So the easiest way is to just select either the structural thermal options in the preferences, and here you can just simply go and select the element type. So here we are selecting this, since we are modeling this 2D solid object. So we're just selecting this quad 4 node 55 element. We click OK and then click close. After selecting the element type, now we are giving it material properties. As we do in structure analysis, we do the same as in thermal analysis. So you just need to go to the material properties, material models, and here we are going to specify this thermal conductivity. Just for the ease, we are writing it 1, but if you know your material like steel or other, you can search in any on the book or on the internet to know that its thermal conductivity, and then you can plug that thermal conductivity in. Here we are choosing 1 just for the ease of this tutorial. And now we click OK and we close the material model window. Now we need to define the geometry. We have defined the model the geometry in ANSYS. So here today we'll be teaching you, okay, how can you model this 2D object? So it's very easy. You just go to modeling, create, and now the 2D objects in ANSYS, the ANSYS call them as areas. So you just need to create an area, and we have selected this option of this creating an area of rectangle by two corners. So you just need to give the center xy coordinate. We are keeping the center xy coordinate as 0. We are giving it a width of 1 and a height of 0.2. So once you input that, we get a rectangle of this dimension of 1 by 0.2 is created. And now we just go and to mesh this mesh our rectangle. We go to this meshing and mesh tool, and we select select this set options in the lines. And once you select, you just, so we want to create a structured mesh. So that I told you in the beam tutorial, that how you can create a chord mesh. So your adjacent lines should be should have equal number of divisions. So here we are, first we are selecting the top and the bottom lines. Click OK. It will ask us the number of element divisions. So we enter 50 for the top and bottom lines and click OK. And you can see that, okay, it has divided the lines into 50 smaller divisions. And then we select the lines on the both sides, click OK. And here we enter 20. You see these lines are short, so we enter 20 for divisions of these lines. And then you go to this mesh tool menu and you click the mesh option here. And once you click, it will ask you, okay, what you want to mesh. So you just select this rectangle with your mouse left button and you click OK. And you can see here that the final element mesh for this rectangle is now generated. So we have defined the element properties, we have defined the material properties, we have created the model that is our rectangle, and now we have meshed this model. Now what the thing next is left is to apply the boundary conditions. So here we go and we select the preprocessor, loads, and thermal, apply, define loads, apply, thermal, and temperature. And as we told in the start in our problem statement, that we will select this top line as the applied temperature of 1 Kelvin. So we apply here temperature of 1 of a unit temperature. You can select depending on your own problem, your own temperature, or you can just repeat this tutorial by changing this temperature value and see what distribution you get for yourself. And again we just go and follow the same path of loads, define loads, apply thermal, temperature on lines, and this time we select both side lines and we keep a temperature of 0 and click OK. Once our boundary conditions have been applied, then we just go and click solve and the current load step options, and we just click OK to begin the solution. And the solution is done. Once our solution is done, we can now see the results. We go to the journal post-processing, plot results, contour plot, and in the contour plot you just need to select this nodal temperature. And here are the details of what this all menu shows. And here your temperature contour plot will be shown, and you can see here that it has clearly followed the boundary conditions. On the sides the temperature is 0, on the top line the temperature of unit 1, and now you can clearly see how the temperature flows for this problem. This is a steady state problem, so this plot we are showing is a thermal equilibrium plot of when the thermal equilibrium is reached. So you will get this kind of plot. Now we are interested to see what is the temperature distribution on the bottom line. Now how we are going to see that? Okay, to plot the temperature distribution on the bottom line, or you can plot this in any inside any section of your interest. Also, the procedure will be same. So you just go to this general post-processing path operations. You need to select now path operations, and you need to define a path. And here we are defining a path by selecting the nodes. Here there are different options. We are selecting it by nodes. And here by carefully be careful when selecting the nodes. We just start it from the left and we click all the nodes one by one from moving towards right. Now you can see that now we are selecting the nodes. You can select even the nodes that are inside or on any part in the geometry of your interest. You can select that, but since we were interested to see this distribution on the bottom line, so we are selecting. There are other ways to select in APDL script, and this tutorial is just a basic tutorial for someone who is doing it for the first time. So we don't want them to be overwhelmed over this ANSYS features. So, but in our future tutorials, we will show you that okay, how we can do all this using an APDL script. That will be very fast. And once you have selected the nodes, now you need to give this a path, a name, yeah, just like we call it a temp line, a temperature line. And here the number of data sets and the number of divisions, you also need to give them. Like here we have keeping them as 30 and 20. And now you just after giving that option, you should go to path operations and map onto the path. You should select this option, and here you just use the label for this item, and now it will ask you what quantity you want to plot. So we are plotting the degree of freedom solution, and only the option available for this degree of freedom solution is the temperature. So you just select that. And here when you now go to plot path item on a graph, we want to plot a graph of temperature on the bottom line. So when you click the on graph option, you will see the name we gave it previously as temp1. You just select that name, and here at the end you will see the temperature profile, how the temperature is varying on the bottom line. The below here you can see the distance, and on top you can see the on your y-axis you can see the temperature, and you can see below you can see the distance of the rectangle. And you can see that okay, how this temperature profile, you can get this temperature profile on any side or on any nodes of your interest in your geometry. So and hopefully this tutorial is useful for you to grasp the basic concept of and the steps that are involved in performing the thermal analysis or heat transfer analysis in ANSYS APTL. You can also list the temperatures if you want to see okay, what are the lists. So you just go to list path items, and here you can see a list. You can copy this list on your notepad and go in Excel and plot if you want to compare these results, or you want to save this analysis results for later post-processing.